everyone, we're going to use series to approximate the definite integral to the indicated accuracy of 3 decimal places. This is x cosine of x cubed dx. The first thing we're going to do is look at the indefinite integral and look at our table of Maclaurin series given here. So I'm going to first look at cosine of x, and that equals the sum n equals 0 to infinity of negative 1 to the power of n times x to the power of 2n divided by 2n factorial. All right, so when you have, let's look at x cubed, cosine of x cubed is just going to equal the sum as n at n equals 0 to infinity and negative 1 to the nth power. And we're going to have, for this piece here, we're going to have x cubed to the power of 2n. So this is going to be 6n, x to the power of 6n divided by 2n factorial. And finally, let's look at this x. So if we have x cosine of x cubed, this is going to be the sum n equals 0 to infinity, and we're going to multiply through by x. So let's take negative 1 to the nth power times x. Now if I multiply this by x, this is going to end up being 6n plus 1. You just add the 6n and the 1, and we have 2n factorial when you divide. Okay, so now when we integrate this, we're integrating this. So let's go ahead and integrate that, and when you do that, you're going to get some c plus the sum from n equals 0 to infinity of negative 1 to the power of n, and then we're going to just add 1, so you can have x to the power of 6n plus 2. We have 2n factorial, and then you also have to multiply by 6n plus 2. All right, so now we're going to evaluate the definite integral, and let's do that. And we're going to use the alternating series theorem. So basically when you do that, you're going to get the integral of the sum n equals 0 to infinity of negative 1 to the nth power times x to the power of 6n plus 2 divided by 6n plus 2 times 2n factorial. So we already integrated that. I should take that off. That's why I was a little hesitant there. And then we're going from 0 to 1 over that interval. Now this is going to equal the sum. When you simplify this part here, we're going to get the sum n equals 0 to infinity. We have negative 1 to the nth power divided by 6n plus 2 times the power of 2n factorial. And that's going to equal 1/2 minus 1 divided by 8 times 2 factorial. Then we're going to have plus 1 divided by 14 times 4 factorial minus 1 divided by 20 times 6 factorial. Now, looking at that, let's look at this one right here. If you just look at that, that equals 1 divided by 20 times 6 factorial equals 1 divided by 14,400, which doesn't give us our decimal places that we need. All right, so let's just do these three here. And when you do those, you're going to get, this is going to be approximately 1/2 minus 1 divided by 16 plus 1 divided by 336. And that's going to be approximately 0.440, correct to 3 decimal places by this alternating series theorem, estimation theorem. Thank you. Have a nice day. Bye-bye.